So we are here at Highcliffe at the boundary between two different councils to show the students the impact of different coastal processes on the coastline, but more importantly, engineering interventions and what effect they have on the transport of sediment and the coastal environment, and therefore the change in the coastal landscape, so the morphology of our coastline. So at this boundary is a very clear distinction between two approaches to managing the shoreline. One of them is to hold the shoreline, in other words, to prevent erosion by any means possible. And that usually takes the form of hard engineering, so the construction of seawalls, putting in gabions or building rocky groins, which play an important role in trapping the longshore transport of sediment, which moves material from the western end of the Christchurch Bay into the eastern edge of the Christchurch Bay, which is on the other side. So the waves predominantly attack from the southwest, and that brings material from the southwestern area all the way towards the eastern area, and that moves sediment along the coastline. Now in this particular area, the boundary between the councils is clearly distinct in the geomorphology because these two councils have two very different approaches to the management. So on this side we've got Christchurch Bay, Christchurch Council and Bournemouth councils, and they want to protect their shoreline because of economic reasons, because they are a big touristic asset as well, and because they provide an important aspect for defending against flooding and erosion. So a lot of money goes into making sure that the coastline does not recede, does not erode, and that includes nourishment of the beach, what we call soft engineering, so regular interventions where large materials of sand or gravel is pumped onto the beach and recycled, reformed on the beach face, but also groins which trap some of this longshore drift of sediment. The other side, which is this side, we've got the New Forest District Council, and for this 1 kilometer or so stretch of the coastline or the shoreline, we've got important geological formations which are protected because they're deemed as being interesting scientifically. So this is classified as a site of special scientific interest, and therefore the policy for this stretch of coastline is actually not to intervene, in other words, to do nothing. And that meant there is a that the natural processes could take their due course, and therefore they could erode the entire cliff face. And that is very clear in the cliff face erosion that you see for this stretch of Naish Farm. So this erosion is actually due to a number of different factors which affect this particular area. So first of all, we've got these groins which are blocking the transport of sediment along the beach, and therefore reducing the amount of material that can feed the beaches at the top of the cliff. And if these beaches were full of sediment, they were much wider, the waves would break on them, they would lose a lot of their energy, and therefore the waves will not reach the toe of the cliffs, and the cliffs would be relatively stable. So a beach is effectively nature's own mechanism of protecting against waves attack on cliff lines. However, because of the starvation of sediment, these beaches are very narrow, there's very little supply of sediment into them, and therefore the waves could propagate all the way to the toe of the cliff. So if we have a high tide or we have a storm surge, these waves can propagate all the way and break straight onto the toe of the cliff, making the cliff face very steep, and therefore removing a lot of the material from the cliff face, exacerbating the erosion problem. Now another problem here is actually the seepage of water through the cliff face. So this is a large layer of mud, it's called Barton clays, and it's about 35 meters or so of sediment. The very top layer, which you just about can see there, is about half a meter of gravel, and that's essentially gravel that was washed during flooding events in the ancient by the ancient Solent River, so talking before the last ice age or during the last interglacial period. That gravel, which is quite angular, is deposited at the very top with some sand lenses within it, and that falling down into the beach actually feeds this beach. So the only sediment supply really here is material falling from the very top of the cliff. The rest of the cliff is actually clay, and it's about 35 meters or so of Barton clay. It's very consolidated, so it's actually quite hard to erode, but the fact that it's built in different terraces or different layers creates different shear faces which allow easy geotechnical failures if they become quite steep. And the fact that the waves break on the toe of the cliff causes these cliff faces to become steep, therefore aiding in the failure along these compound slip faces effectively. Another reason is the seepage of water through the cliff face as well, and you can just about see some old pipelines which were used to regulate water flowing through the cliff face. The rainfall, effectively the water that's seeping through the geotechnical layer, can also cause muddy landslides, and these landslides again fall on top of these shear faces, and so these terraces, which are caused by this compound failure along the shear plane, also have lobate fans of mud landslides, which also are removing material from the face of the cliff. So we've got a very serious case of erosion in this particular area, and the coastline is actually receding at a rate of about 40 centimeters per year. Historically, so just at the construction of these defenses in the 70s, the erosion here reached a few meters per year. So we were losing a lot of coastline, and that was the reason for this current intervention, which is building a fishtail structure, which is mainly to control the water flowing through Chutum Boni, which is effectively a stream of fluid or water going through a very narrow gorge, through a culvert into the sea. So the reason this structure exists is to make sure the water is very well regulated. But we also have this fishtail structure, which is a fishtail groin, and that's mainly to try and change the way the waves break on this stretch of coastline. So they cause diffraction and refraction of the waves, reorienting the waves as they break along the coastline, and creating this hard point here to try and reduce the erosion in this particular area, so that the structure that was built here to regulate the outflow stays in place. So although we've got natural processes taking place, so waves breaking on shorelines, we've got geotechnical failures, and we also have hydrological processes causing further geotechnical failures, a lot of this is also affected heavily by what the engineering interventions in this particular area is. So the reason we're here is just to have a quick look at what are the current processes, but how our interventions in the coastline make a difference to the shape or the general landscape over different timescales. Usually engineering timescales, 20 years or so, up to the next 100 years. Maybe the policies will change. So the current approach for management here means there is no intervention to protect the cliffs here. So they are allowed to erode naturally. That means that the car park and the caravan park at the very top of the cliff is going to face erosion in the near future. At a rate of about 40 centimeters per year, over the next 50 years, a big chunk of that caravan park will be eroded and will be lost to sea. Now, because these are caravans, they're easy to move because they're on stilts, they can be retreated backwards. But there's only such a limited amount of land at the very top before we reach buildings which are placed there. So then at some point a decision will need to be made in the future whether we need to continue doing nothing here and therefore put these houses at risk of failure, of falling into the sea, or do we need to actually change our policy. Now that is a decision that is for engineers, but also most importantly policymakers to make in the future. At the moment, funding for these schemes is based on how many houses are flooded or how many houses are likely to be eroded and therefore fall into the sea. So it's about protecting people primarily, but then it's also about protecting areas such as natural habitats. We've seen this earlier in Christchurch Bay. There's a lot of protection taking place there because Motherford Spit is full of caravans, which are beach huts, which are quite expensive. It also protects a very important area which is deemed by society to be of economic and environmental value. So that decision in Christchurch Bay on the western edge is to protect that section of coastline. What will be the future here? Do we continue doing nothing, or do we have to change our policies so that we need to actually protect this stretch of coastline? Because the rest, so as we move further down east along this coastline, we reach Barton-on-Sea, which is actually quite protected, and then all of this leads into the Solent. We've got Hurst Spit, which protects much of the western Solent. So whatever we do here will have a long-term effect on what happens further downstream, protecting many further properties down the coastline or along the coastline, but also a decision will have to be made as to what our engineering intervention in the future would be.